Hello everyone. Let's start talking about DC voltage for grade 9 students. The objectives of this lesson are to measure DC voltage using a voltmeter and an oscilloscope, measure the electric current I using a digital ammeter, explain the flow of the current through a conductor from a microscopic point of view, know the laws of voltages and currents in the circuit. Finally, define direct current. Let's take a little introduction here about the first battery made by Alessandro Volta in Italy. Volta, though initially galvanized by the work of Galvani, argued that the frog's muscles were simply reacting to the electricity, not producing it. He set out to prove Galvani wrong and sparked a controversy that divided the Italian scientific community. To show conclusively that the generation of an electric current did not require any animal parts, Volta put together a rather messy stack of alternating zinc and silver discs separated by brine-soaked cloth. He built the pile, which consisted of as many as 30 discs, in imitation of the electric organ of the torpedo fish. Since then, the use of electricity has increased extremely. So, this is here in this picture is the first battery made by Volta. Here are the discs, and the poles are made by fish organ. Today it is enough to push a button or turn a switch and a lamp would give light. A motor would start, an elevator would move, a radio or TV would be on a phone, would connect a computer, would connect to an internet. Thus, electricity is becoming an important base of modern technology. So, electricity is a form of energy that can be carried by wires and is used for heating, lighting, and to provide power for machines. Electric current is the rate at which an electric charge passes through a cross-section of a conductor per unit time. So, I equal Q over T. This is the formula of an electric current. Here we see lights in the roads. Direct current voltages is a voltage that sends a current of constant value in a specific direction from the positive pole to the negative pole of the generator. Here the battery is the generator. Voltmeter, this is a multimeter functioning as a voltmeter connecting in a parallel. It measures the electric voltage between 2 points of an electric circuit. It should be connected across the 2 points in a parallel, as we said. Ammeter is an instrument that measures the electric current carried by an electric element. It should be inserted in series in this circuit. So the plus terminal is connected with the plus terminal, and the minus terminal, which is the COM in the ammeter, connected to the negative part of the generator. This figure shows how the ammeter connected in the circuit to measure the current I in ampere, capital A. This schematic diagram of the circuit, we have here a generator, a switch, and a conductor and a voltmeter. Measuring DC voltage using voltmeter. Procedure: take multimeter and put it in a high zone of voltage. Connect the voltmeter across a 6-volt dry cell. As we see here, after reconnecting the battery to the voltmeter, it gives the voltage of 6.34 voltage. To what terminal of the dry cell the COM terminal of the voltmeter should be connected? So it is the negative part, which is here the green or the blue part. What is meant by most convenient range is the range which is suitable for the voltage that we needed for this battery, like 6 volt. So we can make the switch turn on like approximately 10 volt. So 6 volt is in the range of 10 volt. What does the voltmeter indicate? It indicates 6.34 volt. And if we reverse the connection, what does indicate? It will indicate minus 6.34 volt. Since the connections are reversed. Measuring the current. Take a multimeter functioning as an ammeter. Select the highest range in the zone, which is turn the switch in the multimeter to 10 ampere. Connect the ammeter in series with a lamp and a switch across a 6 volt dry cell. As we see here in this schematic diagram, we have the battery of the poles P and N, the lamp and ammeter in series, and switch K closed. So the current will pass through from the positive pole of the battery to the negative pole. Here we have in these figures the schematic of oscilloscope, which is used to measure the voltage and see the shape of this voltage on a screen. Here are the time base in millisecond per division. We have the sources that we needed and the lines and the type of voltages we need. So oscilloscope is an instrument that can be used to visualize and measure the electric voltage between 2 points of an electric circuit. The choice of time base VB, horizontal sensibility is in millisecond per division or microsecond per division in some cases, where 1 millisecond equal 10⁻³ seconds and 1 microsecond equal 10⁻⁶ second. Here we have R, the symbol of an oscilloscope to represent it in a schematic diagram. The oscilloscope is used to display the shape of the voltage across the electric component under study. An oscilloscope can be used to display 1 or 2 voltages. So, an oscilloscope has a channel equivalent to positive terminal denoted by Y, which is here the Y channel, and the ground equivalent to the negative terminal as shown below. Vertical sensitivity, SV. What is this vertical sensitivity? It is vertical amplitude gain or vertical sensitivity or sensibility. It is the potential difference corresponding to a displacement of one division of the spot or a curve. As we can measure 1 megavolt equal 10 power 6 volt and 1 microvolt equal 10⁻⁶ volt. Here in this figure we have how to select the vertical sensitivity in the oscilloscope These are the values here in millivolt for channel 1, and these are for channel 2. And here we can press the button for the source that we need, if we need an AC voltage or DC volt. So here we use DC voltage. This figure represent on a software of oscilloscope. Here are the basics of the oscilloscope. We have this in a channel, takes the position. We have, these are the connecting wires to the battery DC voltage, and here the intensity, how it is changed. This is the power button. We see here on channel 1 it gives 0.5 volt, so SV1 is 0.5 volt per division, and on channel 2 it gives 1 volt, so SV2 is 1 volt per division, and here for one division the T equals 0.5 millisecond. So we use vertical line here for DC voltage and connecting to the battery, since we have a battery which is DC voltage and not AC voltage. Sweeping. It is the horizontal motion of the spot. If we have DC voltage and the sweeping is off, in the absence of voltage, there is a luminous spot at the center of the screen as we see here. And if we have presence of voltage, the luminous spot will be above or below the center of the screen depending on the connection. And if we have sweeping on, in the absence of voltage, the horizontal luminous straight line is at the horizontal axis of the screen as we see here. And if we have sweeping on and the presence of voltage, then the horizontal luminous straight line is above or below the horizontal axis of the screen, as we see here, depending on the connections. So voltage, vertical sensitivity, and ordinate. What are these three terms? We have the relation that's set in using oscilloscope to measure the voltage. We have U equal SV times Y, where U is the voltage, or U maximum is the voltage across the component. Y is the ordinate of vertical displacement of the luminous spot. SV is the vertical amplitude gain or vertical sensitivity or sensibility. We have some notes here that we must pay attention for it. The voltage across the terminals of a connecting wire is null, 0 volt. The voltage across the terminals of a closed switch is null, since it acts as a connecting wire. The voltage across the terminals of an open switch is equal to the voltage of the power supply, since there is no electric current passing through the other connecting wires. The voltage across the terminals of an ammeter is 0 volt, since it acts as a connecting wire and has a negligible resistance. The voltmeter acts as an open switch. Here we have Kirchhoff's first law, which is talking about the sum of current. The sum of the currents flowing into a point or node equals the sum of the currents that flowing out of the node. يعني عندنا الكرنت اللي داخل على هيدي السيركوت، اللي داخل على هيدي البوينت من السيركوت، بيكون بيساوي الكرنت اللي طالع منها. هيدي الستيتمنت بنقول عنها كيرشوف's first law. These are examples here. If we have on this point that the current entering are 2 ampere plus 7 ampere plus 11 ampere equal 3 ampere plus 5 ampere plus x or plus I. So I equal 20 minus 8, it gives 12 ampere. So this I here is 12 ampere according to Kirchhoff's first law. In the second one, the current entering the node are 9 plus I equal the current outsiding this node, which are 10 plus 1 plus 7. So I equal 18 minus 9, it will gives 9 ampere. Now we will use an oscilloscope to measure the voltage. For example, take SV equal S equal 5 volt per division and the time base VB equal 2 millisecond per division. Connect the 6 volt dry cell to the oscilloscope. What is the number Y1 of divisions by switch of the luminous line displaced in this figure? Y1 is approximately, it is 1.2 division according to this figure here. The question is how to calculate the voltage U. So we use the formula U equal SV times Y1 equal 5 times 1.2, it gives 6 volt. Connect a digital voltmeter across the dry cell now. What values it indicates? So it gives 6 volt. Is this value equal to that calculated above from the oscilloscope? Yes, it's the same. So we can say that oscilloscope is used as a digital voltmeter to measure the voltage across a battery. Laws of uniqueness of voltages and currents. Law of uniqueness of currents: when many components are connected in series, the current carried by all these components is the same. So I equal I1 equal I2. And the law of uniqueness of voltage: when many components are connected in a parallel, then the voltage is the same across all these components. So V equal V1 equal V2, or U equal U1 equal U2. So we see here in this circuit that L1 and L2, the two lamps, are connected in series, so they have the same current. These two voltmeters connected in a parallel across these two lamps, and a third voltmeter connected in a parallel across the battery. So it gives the voltage of the battery or of the circuit all above. And here we have the ammeter in series with L1 and the ammeter in series with L2, and switch K is closed. Now let's talk about law of addition of voltages and currents. Law of addition of voltages: when many components are connected in series, the voltage across the group is the sum of the voltages across the components V equal V1 plus V2. So as we see here, there is two branches here. So the voltage will divides where in series and not in a parallel. But here in a parallel, the current will divides. So the law of addition of currents is applied when many components connected in a parallel. The main current in the circuit is the sum of the branch currents carried by all these components. So I is equal to I1 plus I2 here. Now let's go on to solve this question. We have voltage and current in an electric circuit. In the adjacent figure, UPN equal 12 volt, and all the lamps are identical, so they have the same components. The switch K is opened, as we see here. Determine the voltage across the switch K. So we said before that when switch K is open, so it has a voltage equal to the voltage of the generator or a battery, which is here 12 volt. Determine the voltage across each lamp. Justify your answer. Here, since switch K is opened, then the lamps have 0 voltage. The switch K is closed and UAB equal to 6 volt. So now we close the switch and the voltage across this lamp in the terms or the poles UAB equal to 6 volt. Redraw the figure, then indicate the direction of the current in all the branches. Let's see here. So we have in this figure, when you close the switch, the direction of the current passing through L1 then divides into the two branches here for L2, L3, then to L4 and L5. Determine the voltage across lamp L1. Since UAB equals 6 volt, then UL1 equal to 6 volt. Determine UBI and then determine the voltage across lamps 2, 3, 4, and 5. As we see here, L2 and L3 are connected in series, and all of them connected in a parallel with these two lamps. So we can say that apply law of addition of voltages UPN equal UPA plus UAB plus UBI plus UIJ plus UJN and UPA equal UIJ equal UJN equal 0 volt since they are connecting wires. Then 12 volt equals 0 volt plus 6 volt plus UBI plus 0 volt plus 0 volt, then UBI equal 6 volt. So UL2 equal UL3 equal UBI equal 6 volt parallel grouping, and the two lamps are identical. Then UL2 equal UL3 equal 6 volt over 2 equal to 3 volt. Since the two lamps are identical, so they have the same voltage. Similarity, UL4 plus UL5 equal UBI equal 6 volt. Parallel grouping, and the two lamps are identical. Then UL4 equal UL5 equal to 6 volt over 2 equal 3 volts. So L4 equal 3 volt and L5 equal 3 volt. Part 4. Connect a voltmeter to measure the voltage across L5 and indicate the common terminal to obtain a positive reading. So we need across L5 to indicate a voltage. We connect a voltmeter. The voltmeter must be connected in a parallel to L5, and the common terminal must be connected to the negative terminal to obtain positive reading, as we see here. Now, in the part 5, if the main current sent by the generator is 500 milliampere, determine the current in each lamp. So he said that the main current I is 500 milliampere. Then the current to across L1, since it is in series with the generator, it will have the same current of the generator, which is 500 milliampere. Then, according to law of addition of current in a parallel grouping, IL1 equal IL2 plus IL4. In addition, the branches are identical. Then IL2 equal IL4 equal ILI equal IL1 over 2 equal 500 milliampere over 2 equal 250 milliampere. So since they are identical lamps, then they have the same current and they are connected in series, so they have the same current. Here in we have two branches, so the main current will divide by its half. So we have 250 milliampere here and 250 milliampere here. If a connecting wire here joins the points A and B, what would happen to the brightness of the other lamps? Justify your answer. So we make a connecting wire here. So this lamp will cancel. So the brightness of other lamps will be more, or will it increase? So if we're connecting wire joins the points A and B, then U lamp A1 equal UAB equals 0 volt. Then UL1 equal UL2 equal UPN over 2 equals 6 volt. Property of series grouping of identical lamps across the terminals of a generator. And UL4 equal UL5 equal to UPN over 2 equals 6 volt. Property of series connection of identical lamps across the terminals of a generator. Then the brightness of the other lamps will increase since the voltage across the terminals of each lamp increases from 3 volt to 6 volt. Thank you for watching this session today. We hope you feel that the information are clear. See you in the other videos. Thank you.